The moon is our constant companion here on Earth. It inspires culture, governs the tides, and supports life in countless little ways. But what would happen if we just blew it up?
America can, should, must, and will blow up the moon.
Outside of those two, most scientific speculation about a moon-free future suggests that some outer force like a comet or rogue planet would be responsible. The effects of losing the moon like that would be much the same as if humans intentionally blew it up, just with a few stranger consequences. Also, so we're clear, this isn't scientifically accurate.
And we'll be doing it during a full moon, so we make sure we get it all.
Anyway, the amount of gravitational energy holding the moon and Earth together is 120 million trillion gigajoules. Anything less than that might break the moon into a few pieces, but the gravity is such that they'd eventually regroup into a familiar spherical shape and resume rotation. To prevent that from happening, any attempt to destroy the moon would require digging shafts hundreds of miles into its core and filling them with roughly 600 billion high-powered nuclear bombs. After that monumental mega explosion, all these moon fragments would have to go somewhere, and a lot of them would head straight for Earth. They'd fall slowly thanks to the planet's orbit keeping their speed in check, but the sheer volume of debris, however small, could fatally strike countless people and cause property damage worldwide. The kinetic energy of those moon rocks would be an even bigger problem. Earth's atmosphere would absorb it upon entry, raising temperatures permanently, and the heat would keep building up until no living thing could survive. In other words,
we're Earthlings, let's blow up Earth things.
The moon and the Earth enjoy something of a symbiotic relationship, with the ocean tides as their common link. As a planet rotates, it generates a strong centrifugal force. This force, combined with the pull of gravity from the moon and the sun, drives constant and vigorous movement through the oceans, which cover about 3/4 of the surface of the planet. The moon pulls on the Earth about twice as hard as the sun does, simply because it's so much closer. If it were to disappear, tidal activity would be significantly lessened. Scientists know this because when the moon took shape, it was much closer to the Earth, resulting in bigger tides and waves than those we see today. The more distant the moon, the less effect it has on the seas. A calmer ocean isn't a good thing. Not for surfers, and certainly not for life in, under, and above the water. Tides manage the temperature of the ocean, with currents of warm and cold water circulating around the world and creating life-sustaining conditions. These currents also help direct the winds and make coastal areas some of the most temperate places on Earth. No moon would mean barely any tides, making the ocean too cold and too hot for life in some spots. Fewer heat-regulating winds also would exacerbate climate change and raise the temperature of the Earth, and not just on the beaches. The loss of the moon would be the first step in a catastrophic domino effect. Without the moon driving the tides, currents would stall, and they'd be unable to regulate the traffic of undersea life or the temperature of the sea. Starved of food, much of the ocean's ecosystem would die off, while a lot more of it would expire from the sudden shift in temperature. You probably gathered this already, but obviously that in turn would create a negative economic and lifestyle impact for anyone who lives or works near an ocean, whether that's on an island or in a coastal area. That's a lot of people, somewhere in the billions, as about 75% of the world's entire population lives within about 30 miles of an ocean. Those individuals use beachside intertidal zones to acquire the food they eat or put into the global seafood economy. Without tides, fishing and seafood sourcing could end or be rendered completely unsustainable. And if the ocean food chain collapses, humans would lose a major food source. The result? Poverty and widespread starvation. I guess more poverty and widespread starvation, technically. About 4.5 billion years ago, scientists theorized that a planet they call Theia collided with Earth so violently and at such an odd angle that it broke off enough material to form the moon. Back then, a day on Earth, defined as the time it takes for the planet to rotate once on its axis, lasted only 4 to 5 hours. The mutual gravity the Earth and the moon put on each other slows down that rotation, and gradually more so over time. Each century, the moon makes Earth's rotation about 0.002 seconds longer. That tiny change adds up, giving us the 24-hour day we're used to now. Should the world discover one day that the moon has left its orbit or been destroyed in some way, one of the most immediate effects would be on time itself. Without the moon's gravitational tug, Earth would be free to move at its original natural rate.
I was strolling on the moon one day.
Yeah, about that day. The Earth would rapidly return to a much speedier pace, approaching its original rotation. A day would no longer last 24 hours, but closer to 4 or 5, just like in the beginning. And then you'd work 2 straight days, 8 days a week. Guess I'd throw the calendars off too. The reason Earth experiences 4 seasons is not just because of its tilt, but also because of the moon's stabilizing pull. Earth tilts at a 23.5-degree angle relative to the sun, and that tilt holds steady thanks to the moon. Over about 26,000 years, that angle shifts no more than 2.4 degrees. That leads to only a slight shake unnoticeable to human beings. But more importantly, it makes every season roughly the same length and occur at the same time every year. Without the moon, all of that stability and consistency from a stable rotating axis would end. The Earth would be subject to rolling around as it orbits the sun, without warning and arbitrarily too. Living things wouldn't necessarily physically feel what astronomers call an unpredictable wobble, but it would change the idea of a 4-season year with 24 hours in a day. Some parts of the planet may not experience daylight for long stretches, while others could be stuck in near constant darkness. Important plants and crops would have a hard time growing in such an environment, while animal life would be tremendously disrupted too. It's a given that without the moon, Earth would be plunged into much deeper and longer-lasting darkness. While this would certainly take some time for humans to get used to, that new situation would prove tremendously difficult for animals.
They're great survivors.
Species that have evolved to do their hunting at night, such as bats and owls, would be disoriented by the new and inconsistent nighttime cycles. Confusion over when to eat, sleep, and mate could ripple through populations worldwide. Not only that, but prey animals would gain an unexpected advantage over their predators. In addition to nocturnal animals, numerous creatures have biological cycles that connect to those of the moon. Without its steady clues, birds that use moonlight to track their migration wouldn't know where to go. Coral spawning in the Great Barrier Reef could also be interrupted or end entirely without the rise of the moon giving sea life its signal to begin. Through decades of observation from Earth, along with multiple missions to the moon, both manned and unmanned, scientists have learned a great deal about our planet's breakaway neighbor and chief satellite. As the nearest space object, the moon has always been the natural starting point for cosmic research. Scientists use it to study how things form, move, and interact, not only in Earth's orbit, but across the galaxy and beyond.
What could space be? What could it be made of? What the heck is all those lights out there?
Losing the moon would be a huge setback from a research perspective. Scientists have only just begun to understand it, and it may hold the key to future technological advancements, or even serve as a source of fresh water for a planet facing an environmental crisis. An absent moon would of course mean nobody could analyze it, but it would also limit scientific research into the history of our home world. Because the moon was once part of our planet, it offers rare insights into Earth's history and evolution. Without that guide, we may miss out on critical knowledge about its past and future. For as long as humans have lived on Earth, the moon has been right there with them. As a constant presence, sometimes intimidating, sometimes reassuring, it took on supernatural status in many ancient cultures. Lunar calendars shaped daily routines and inspired rituals, as well as some of humanity's earliest expressions like stories, songs, and artwork. In caves in Western Europe, researchers have found evidence that humans followed moon cycles more than 30,000 years ago. Civilizations like the Celts, Incas, and Mayans left records showing their respect for the moon and built timekeeping systems around its movements, image, and cycles. Even today, the moon and its phases play a role in religious and spiritual practices around the world. It's safe to say it would be catastrophic if such a central element in culture and ritual were to simply vanish. If the moon were to suddenly disappear, it would bring about a profound and permanent change to life on Earth. The planet would become hard to live on, either all at once or gradually, depending on the threat. That loss could even spark the long-speculated science fiction-inspired idea of humanity's mass exodus from Earth. In a tragic twist of irony, though, the very thing that might drive people to abandon Earth would also make leaving it much more difficult. In 2020, scientists confirmed the existence of water on the moon's surface. That discovery suggested that future missions to the natural satellite could be more than just exploratory. The presence of life-sustaining fresh water meant that humans might one day colonize the moon and live there indefinitely. But that dream, of course, would vanish if the moon itself did. Travel to solid celestial bodies beyond the moon, or where the moon sits, would also become more difficult. Space programs have long theorized that the moon could serve as a staging point for astronauts and spacecraft heading to other planets in the solar system. Without it, the challenge of mounting long-haul space missions would only grow. While Earth would become essentially uninhabitable for all life, if the moon were to suddenly divorce its natural cosmic partner, there is a bright side, or should we say a dark side. Research in amateur astronomy would be greatly enhanced without the moon getting in the way. As the closest, and thus the largest and most luminous, object in the night sky, the moon's powerful light renders countless celestial objects virtually invisible without a high-grade telescope. There are plenty of distant stars that astronomers and casual stargazers can see from Earth with or without aid when the moon is present. But without it, we'd see countless more. A moon-free existence could usher in a new golden age of astronomy, with previously unseen stars, galaxies, constellations, and even planets noticed and named for the first time. On the other hand, less moonlight would make the sky much darker, meaning researchers might have to develop new tools and strategies to adapt. It's a scientific fact that the moon is slowly drifting away from Earth, but that's just how gravity works, and the process is so gradual that the moon isn't going anywhere anytime soon.
There we go.
Even an asteroid isn't a real threat. It would have to be extraordinarily massive to knock the moon out of its stable orbit. Plus, we have advanced technology to detect asteroids well in advance. It would take a planet hurtling at a tremendous speed from far beyond our solar system to collide with the moon and overcome the gravitational pull that binds it to Earth. Even if someone tried to carve their name into the moon, it wouldn't really have that much of an effect. For the moon to be broken up or freed from its orbit, an event as massive as the one that formed it originally would have to occur. That's extremely unlikely. Wandering planets aren't unheard of. There could be as many as 400 Earth-sized ones drifting through the Milky Way. But the chances of one of those finding itself on a direct collision course with the moon are astronomically slim.